Hello everyone, my name is Simon. Today we'll discuss hypothesis testing. We will briefly see what hypothesis testing is. We will see different types of the outcomes of hypothesis testing, and we will see the different types of error during hypothesis testing. We will also briefly see what p-value is and the tests of significance. So what's hypothesis testing? Hypothesis testing is statistical method which helps us decide whether the observed result is due to a random chance or it is the reality or reflects the true effect. So always there are two opposing claims, the null hypothesis, which is denoted by H0, and the alternative hypothesis, which is denoted by H1 or HA. So the null hypothesis says there is no difference, no association, or no effect. And the alternative hypothesis says there is a difference, there is an association, or there is an effect. So let's simplify this with an example. Let's say we are comparing two drugs used to treat community acquired pneumonia. The standard drug denoted by S and the new drug denoted by N. So the null hypothesis says that N is equal to S, which means the new drug is similar in efficacy compared to the standard drug. That means there is no difference. H1, which is the alternative hypothesis, states that the new drug is better or more efficacious than the standard drug. So the researchers claim the statement that says different exist is alternative hypothesis. So our goal is to reject the null hypothesis. So there are four possible outcomes of hypothesis testing. The first one is the uh, power, which is in reality, there is a difference, and our experiment also detects the difference. We call this power, which is the chance of detecting a difference. So the higher the power, the better our research is. The second one is alpha, which is also known as type 1 error. So in reality, there is no difference, but our experiment says there is a difference. So it is concluding there is an effect or a difference when there isn't one in reality. So we call that type 1 error or alpha error. The other one is beta error or type 2 error. So type 2 error is when in reality a difference exists, but our research or experiment fails to detect the difference. So we call that beta. So the higher the power we have or the less beta we have, our ability to detect the difference is much higher. So our research will be statistically more significant. So what's p-value? P-value is the probability of observing a result or results more extreme considering the null hypothesis actually true. So the threshold for rejection of alpha is typically 5% or 0.05%, and we call that the significant level. So as a decision rule, if p-value is very low, that means if it is less than significance level or less than 0.05, we reject the null hypothesis. If it is greater than 0.05, we fail to reject the null hypothesis. So wording is very important here. We either reject the null hypothesis or we fail to reject the null hypothesis. So there are different tests to calculate the p-value, and we will see them one by one. So how do we test our test of significance to calculate the p-value? So it depends one on the type of data. Is it the continuous data or categorical data? Continuous data such as height, weight, and temperature, these are in numbers. The categorical data, however, these are reported as in percentage or in proportions. The second one is the number of groups we are comparing. Are we comparing two groups or are we comparing more? So that's the factors which affects our choice. So let's see the first one, comparing the means of continuous data and comparing two groups. If we are comparing two groups, we are going to use the t-test. There are two types of t-test, unpaired and paired t-test. Unpaired t-test, we are comparing the means in two different groups. For example, let's say we are comparing the blood pressure in treated and untreated patients. Paired t-test, we are still comparing two groups, but these groups are the same groups before and after treatment. For example, let's say comparing blood pressure of a group before and after treatment with antihypertensive. We use paired t-test. So the other one is ANOVA, which is analysis of variance. We are comparing continuous data, but we are using it for more than three or groups. So as an example, let's say we are comparing blood pressure across three antihypertensive drugs. We use ANOVA. So what is the right test comparing proportions? So proportions are categorical data. We use chi-square test. So let's say we are comparing between the association between smoking and myocardial infarction. So the answers will be yes or no. That means this percentage of smokers have myocardial infarction. So it is reported in proportions of percentage. We are using the categorical data. So in summary, let's say we follow three steps. First, we identify the type of data. Is it continuous data or categorical data? Then we identify how many groups we are comparing. So in continuous data, if we are comparing two groups, we use t-test. If we are comparing three or more, we use the ANOVA. After that, we calculate our p-value. Then if our p-value is very low, we reject our null hypothesis. That means our research is statistically significant. For example, let's say we want to compare the complication rate, for example, the surgical site infection rate between open and laparoscopic appendectomy. What do we use? So here it is whether there is surgical site infection or not. So it is categorical data. So we use chi-square test. Thank you for listening.